Alright, let's get right into it. Number 10. In 2015, a citizen scientist working with NASA's Kepler telescope found a star dimming so strangely that professional astronomers openly debated whether it might be surrounded by an artificial structure built by another civilization. Astronomer Tabetha Boyajian at Yale University, working with citizen scientists through the Planet Hunters project, published a paper in 2015 describing KIC 846285-2, a star roughly 1,470 light-years away that dimmed erratically and dramatically, at times losing up to 22% of its brightness, far beyond what any orbiting planet could ever cause by passing in front of it. Astronomer Jason Wright at Penn State University publicly suggested in 2015 that the pattern was consistent with what astronomers call a Dyson swarm, a theoretical megastructure built by an advanced civilization to harvest energy directly from a star, and the object quickly became known worldwide as Tabby's star. In 2018, Boyajian led a follow-up study using funding partially raised through public crowdsourcing, publishing results in the Astrophysical Journal Letters, showing the dimming affected different wavelengths of light unevenly, a pattern more consistent with a cloud of uneven dust than a solid object. This ruled out a single megastructure, but it did not explain where such an enormous, irregular dust cloud came from, or why no other star observed by Kepler behaves anything like it. As of 2026, no complete explanation has been confirmed, and Tabby's star remains the single most famous unexplained dimming pattern ever recorded by a space telescope. Number 9. In 1950, an astronomer photographed a galaxy shaped like a perfect ring, surrounding a completely separate galaxy at its center, and 75 years later, nobody has fully explained how it formed. Astronomer Arthur Hoag, using the Palomar Observatory in California, discovered the object in 1950 and published his findings that same year, describing what appeared to be a nearly perfect ring of hot, young blue stars encircling a completely separate, older, yellow galactic core, with almost nothing but empty space visible in the gap between them. Hoag himself was uncertain whether he was looking at a gravitational lensing illusion or a genuine physical structure. Hoag's object, as it became known, sits roughly 600 million light-years away, and modern imaging by the Hubble Space Telescope, including detailed photographs released in 2001, confirmed it is a real, physical ring galaxy, not an optical illusion. The leading theoretical explanations, including a galactic collision that stripped material into a ring, or an unstable bar structure that eventually dissolved, remain unconfirmed, and objects that look anything like Hoag's object are so exceptionally rare, only a few hundred candidates exist in the observable sky, that astronomers still cannot agree on a single formation process that reliably explains any of them. A galaxy with a hole punched cleanly through its structure, surrounding a completely intact second galaxy at its core, remains one of the strangest confirmed shapes ever photographed in the universe. Number 8. A star discovered in 1961 contains chemical elements that should not physically exist there at all, because they decay into nothing within a matter of days. Polish astronomer Antoni Przybylski, working at Australia's Mount Stromlo Observatory, discovered a star in 1961 with a spectrum so unusual that decades of follow-up analysis have never fully explained it. Przybylski's star contains extraordinarily high concentrations of heavy, rare earth elements, but the truly disturbing detail, confirmed through spectroscopic analysis published by multiple research teams since the 1960s, is the apparent presence of promethium and technetium, radioactive elements with half-lives measured in years or days, meaning they should completely decay away almost immediately, unless something inside the star is actively producing them right now, in real time. No confirmed nuclear process has ever fully explained how a star could continuously manufacture and sustain these unstable elements at the surface, where they are being directly observed. Some researchers have proposed the star's powerful magnetic field, one of the strongest ever measured in any star, may be dragging freshly created radioactive material up from its interior faster than it can decay. Others suggest the readings themselves may involve spectral misidentification. As of 2026, Przybylski's star remains formally unexplained, a stellar object that appears to be doing something to the periodic table that stars are not supposed to be capable of doing. Number 7. In 2013, astronomers measured the age of a nearby star using the Hubble Space Telescope and got a number that is technically older than the universe itself. Astronomer Howard Bond at the Space Telescope Science Institute led a team that published refined age measurements of HD 140283, a star located roughly 190 light-years from Earth, in a 2013 paper presented at the American Astronomical Society. Using Hubble's fine guidance sensors to precisely measure the star's distance through parallax, the team calculated its age at approximately 14.46 billion years, plus or minus 800 million years. The problem is immediate and obvious. The universe itself, based on measurements of the cosmic microwave background by the Planck satellite, is approximately 13.8 billion years old. A star cannot be older than the universe that contains it. The star, nicknamed the Methuselah star after the oldest figure in the Bible, sits at an age that, accounting for the margin of error, overlaps directly with impossibility. Bond's team has stated the uncertainty range technically allows the star's true age to fall just under the age of the universe, resolving the paradox mathematically, but only barely, and only by relying on the outer edge of the measurement's error bars. HD 140283 remains the oldest confirmed star ever precisely measured, sitting right at the exact boundary of contradicting the age of everything that exists. Number 6. In 2015, a survey telescope detected an explosion in space twice as bright as any supernova ever recorded, and astronomers still cannot agree on what kind of event actually produced it. The All-Sky Automated Survey for Supernovae, a network of small robotic telescopes, detected an object designated a SAS and 15LH. In June 2015, astronomer Subo Dong at Peking University led an international team publishing findings in the journal Science in 2016. Reporting the event released roughly twice the total energy output of the previous record-holding supernova, briefly outshining the combined light of an estimated 570 billion suns. If it was a standard supernova, that energy output should be physically impossible under any known model of how a dying star can explode, forcing researchers to invent a new theoretical category called a superluminous supernova just to accommodate the observation. But astronomer Krzysztof Stanek at Ohio State University, part of the same discovery team, publicly noted the possibility that the event was not a supernova at all, but a star being torn apart after wandering too close to a supermassive black hole, a tidal disruption event that only coincidentally resembled a stellar explosion in the data. As of 2026, both explanations remain actively debated in published literature, and a SAS and 15LH continues to sit in astronomical records as the brightest confirmed explosion in the observable universe, with astronomers still formally uncertain what category of event they are even describing. Number 5. In 2018, a robotic sky survey caught an explosion that brightened and faded roughly 10 times faster than any known supernova, and 3 years of analysis have failed to settle what caused it. The Atlas survey detected an object designated AT2018 Cow, quickly nicknamed the Cow, in June 2018. Unlike ordinary supernovae, which typically take weeks to reach peak brightness, the Cow brightened to its maximum luminosity in under 3 days, then faded almost as rapidly, a behavior so unusual it was classified as a fast blue optical transient, an entirely new category astronomers had only begun formally documenting. Astronomer Anna Ho, then at Caltech, led a 2019 study published in the Astrophysical Journal using data from multiple observatories, including X-ray telescopes, concluding the event was most likely powered by a newly formed black hole or neutron star actively feeding on surrounding stellar debris, producing the extreme brightness through a process closer to active accretion than a standard explosion. Other researchers have proposed alternative explanations involving a star being tidally disrupted by an intermediate mass black hole. No single model has achieved full scientific consensus. Astronomers have since identified a small handful of similar fast blue optical transients, but the Cow remains the best studied example of an entirely new class of cosmic explosion that simply did not fit into any category that existed before 2018. Number 4. When a star exploded in 1987, close enough to observe in extraordinary detail, physics predicted it should leave behind a neutron star, and for 32 years nobody could find it anywhere. Supernova 1987A, observed in the Large Magellanic Cloud roughly 168,000 light-years away, remains the closest supernova explosion witnessed since the invention of the telescope, giving astronomers an unprecedented, detailed view of a dying star's final moments. Every accepted model of stellar collapse predicted the explosion should have left behind a dense neutron star at its center, and in fact, a brief burst of neutrinos detected in 1987 by underground observatories strongly suggested exactly that had happened. But for over 3 decades, no telescope operating across radio, optical, or X-ray wavelengths could locate any confirmed trace of it, hidden somewhere behind an expanding, thick cloud of stellar debris. In 2019, astronomer Phil Sagan at Cardiff University, using the ALMA radio telescope array in Chile, published findings in the Astrophysical Journal identifying a small, unusually warm clump of dust at the explosion's center, consistent with a neutron star heating its immediate surroundings from within. The neutron star itself has still never been directly imaged or confirmed. Physics insists it must be there. 3 decades of the most advanced instruments ever built have still not been able to definitively prove it. Number 3. Astronomers discovered a planet or failed star with a ring system so massive that if it replaced Saturn's rings in our own solar system, they would be clearly visible from Earth every single night, stretching most of the way to where the Moon orbits. In 2012, astronomer Mamajek at the University of Rochester led a team analyzing unusual dimming patterns around a young star system designated J1407, publishing findings that identified an orbiting companion, likely a giant planet or small brown dwarf, surrounded by an immense ring system roughly 200 times larger in diameter than the rings of Saturn. The object, informally nicknamed Saturn on steroids, produced a dimming event in 2007 that lasted 56 days, far longer and more complex than any planetary transit ever recorded, indicating dozens of individual, distinct rings. Mamajek's team calculated that gaps within the ring structure strongly suggest the presence of forming exomoons, unseen satellites carving pathways through the surrounding material, similar to processes observed within Saturn's own rings much closer to home. No follow-up direct imaging has ever confirmed the ring structure independently because the entire detection relies on a single, extraordinarily long dimming event captured by ground-based survey telescopes. Astronomers continue to monitor the system for a repeat transit, expected sometime near 2038, in hopes of finally confirming whether one of the largest confirmed structures ever detected around another star is really as immense as the original data suggests. Number 2. In 2019, gravitational wave detectors recorded 2 black holes colliding that, according to the accepted physics of dying stars, should not have been able to exist in the first place. On May 21, 2019, the LIGO and Virgo gravitational wave observatories detected a collision between 2 black holes with masses of approximately 85 and 66 times the mass of our Sun, publishing the confirmed results in Physical Review Letters and the Astrophysical Journal Letters in 2020. The problem is a phenomenon called the pair instability mass gap, a range of stellar masses, roughly between 65 and 135 solar masses, where physics predicts a dying star should be completely destroyed by runaway thermonuclear reactions before it can ever collapse into a black hole at all. The larger of the 2 colliding black holes sat directly inside that supposedly forbidden mass range, meaning it should never have been able to form through the collapse of a single star under any currently accepted stellar model. The resulting merger produced a black hole of roughly 142 solar masses, the first confirmed intermediate mass black hole ever directly detected, designated GW 1905-21. Some researchers have proposed the progenitor black holes may have formed through earlier mergers of smaller black holes rather than a single star's collapse, a process called hierarchical merging. As of 2026, the full explanation for how black holes inside the forbidden mass gap can exist at all remains one of the most actively debated open problems in modern astrophysics. Number 1. At the exact center of our own galaxy, astronomers watched a cloud of gas approach the supermassive black hole, expecting to witness its complete destruction in real time, and instead, it walked away intact, suggesting it may have been hiding something inside it all along. In 2011, astronomer Stephen Gillison at the Max Planck Institute for Extraterrestrial Physics identified an object called G2, an apparent cloud of gas, on a direct collision course with Sagittarius A star, the supermassive black hole sitting at the center of the Milky Way, roughly 26,000 light-years from Earth. Astronomers worldwide prepared to observe an unprecedented event, the black hole's immense tidal forces tearing the cloud apart during its closest approach, predicted for 2014. The destruction never happened. Astronomer Andrea Ghez at UCLA, who would later share the 2020 Nobel Prize in Physics for her work studying the black hole at our galaxy's center, led follow-up observations showing G2 survived its closest approach intact, its structure barely disturbed by gravitational forces that should have shredded a simple gas cloud completely. The leading explanation, published across multiple follow-up studies, is that G2 is not a simple cloud of gas at all, but a star, likely surrounded by a thick envelope of gas and dust, with enough gravitational cohesion of its own to resist the black hole's pull. If true, an object we initially identified as one thing, an expendable cloud about to be destroyed, was quietly something else entirely. a hidden star, wrapped in disguise, that simply refused to die exactly where and when our own physics insisted that it had to. If you want to see more videos like this, click the video on screen now and make sure to subscribe.